Alright guys, so we're going to start reviewing for the third test of the second marking period. It's going to be on December 20th, which is the Friday before the break. Remember, there's extra help on Thursday, the 19th. For number 1, algebraically determine if x plus 7 is a factor of that, and then explain. So you could do long division on this, or you could do the remainder theorem. So the remainder theorem says that if x plus 7 is what we're looking for, I set that equal to 0, and then I solve. I get x equals negative 7. So now if I plug in negative 7, 4 times negative 7 to the third plus 26 times negative 7 squared minus 15 times negative 7 minus 7. I plug that in, I get 0. So this function contains the point negative 7 comma 0. So is it a factor? Yes, it's a factor because the remainder, or the y value, the remainder slash y value is 0. So again, you can do long division. If you do long division correctly, you should get a remainder of 0, which also means it's a factor. So either way. Number 2, if x plus 6 is a known factor of that, algebraically determine the remaining linear factors. So x plus 6 is a known factor. So if I do long division, I can figure out it's x plus 6 times what to give me this. So 3x to the third divided by x is 3x squared. I multiply that out, I get 3x to the third plus 18x squared. I put that in parentheses and I subtract. 3 minus 3 cancels. 8 minus 18 gives me negative 10x squared minus 68x. And then I go again. So that's one round. Negative 10x squared divided by x is negative 10x. I multiply that out. I get negative 10x squared minus 60x. Put that in parentheses and I subtract. I get negative 8x minus 48. Again, negative 8x divided by x is negative 8. I multiply that out. I get negative 8x minus 48. Parentheses and subtract. I get a remainder of 0, which makes sense because x plus 6 is a known factor, so it should have had a remainder of 0. So now I know that this is equal to x plus 6 times 3x squared minus 10x minus 8. So those are two of my factors. The question, though, wants the remaining linear factors, and 3x squared minus 10x minus 8 is quadratic. So I'm going to have to be able to factor that even further, and I'm going to factor that using master product. So two numbers that multiply to be negative 28 but add to be a negative 10 are going to be negative 12x plus 2x minus 8. Split it down the middle, take out 3x, I'm left with x minus 4. On the other side, I take out a positive 2, I'm left with x minus 4. So this is x minus 4 times 3x plus 2, and I still have that x plus 6 as well. So my three linear factors are right here. Numbers 3 and 4, these are rational equations. So for number 3, I factor all the denominators. There's nothing I can do here. X minus 1 and x minus 3, you can't factor. So now I'm going to figure out what my LCD is. To cancel out an x minus 1, I need an x minus 1. So that goes on top of everything. And then to cancel out an x minus 3, I need an x minus 3. So that also goes on top of everything. And now I see what cancels. So x minus 1's cancel. I have 1 times x minus 3. Then I have x minus 3 cancels. I have plus 7 times x minus 1 equals x times x minus 3. So this is x minus 3 plus 7x minus 7 equals x squared minus 3x. On the left side, this turns into 8x minus 10 equals x squared minus 3x. Set it equal to 0, x squared minus 11x plus 10. And then if I go through and I do the whole master product, it would turn into x minus 1 times x minus 10. So I get x is equal to 1 and x is equal to 10. However, x is equal to 1 gets rejected because if I plug it into this x minus 1, I get a 0 in the denominator, which we know makes the expression undefined. Okay, so my only answer to number 3 is x equals 10. Number 4. So for this one, it's a little bit trickier because I have to factor this. So this is x over x plus 1 minus 5 over x plus 2 equals 5 over, if I factor the denominator, I get x plus 1 times x plus 2, which is super convenient for us because those are the other two factors. So my LCD is going to be x plus 1 times x plus 2. So I put that on top of everything. Okay, x plus 1 gets rejected. This is x times x plus 2. X plus 2 gets rejected, so I have minus 5 times x plus 1 equals x plus 1 gets rejected, x plus 2, not rejected, gets canceled out, I'm sorry. X plus 2 gets canceled out, so I have equals 5. So this is x squared plus 2x minus 5x minus 5 equals 5. X squared minus 3x. If I subtract that 5 over, I have minus 10 equals 0. So now when I do master product on this, I get x minus 5 times x plus 2 equals 0. Set up the t-chart, so I get x is equal to 5 and x is equal to negative 2. So now the x equals negative 2 gets rejected because negative 2 plus 2 gives me a 0 in the denominator, which we know I can't have. Numbers 5 and 6 are absolute value equations. So absolute value equations, you want to get the absolute value bars by itself. So I'm going to subtract the 6. So this is 3 times the absolute value of 4 plus 4x equals 12. Divide by 3. You cannot multiply the 3 times the 4x plus 4. You can't distribute to inside of the absolute value. So I have the absolute value of 4 plus 4x is equal to 4. I set up two equations. 4 plus 4x equals 4, and 4 plus 4x equals negative 4. That's absolute value. It could be positive or negative, and it'll give you the same number. So when I solve this, I get 4x is equal to 0, so x equals 0. Over here, 4x equals negative 8, so x equals negative 2. Have to plug them both back into the original question. When I plug 0 in, it works. When I plug negative 2 in, it also works. So nothing gets rejected to number 5. You get two answers. For number 6, again, I'm going to get the absolute value bars by itself. So I'm going to add the 5 over first. So the absolute value of x plus 1 is equal to 2x plus 5. From here, I set up two equations. One of them is the original, x plus 1 equals 2x plus 5, and the other I have to make sure to distribute the negative, so x plus 1 equals negative 2x minus 5. On the left equation, if I subtract x to both sides, I get x over here. If I subtract the negative 5, this turns into negative 4, so I get x equals negative 4. On the right side, if I add 2x, I get 3x. Subtract the 1 is negative 6. I get x equals negative 2. You have to plug your answer choices back in. When I plug in negative 4, it does not work, but negative 2 does work. So my answer to number 6 is x equals negative 2. Numbers 7 through 10 deals with evaluating a piecewise function. Now, on the bottom of your review sheet, I tell you that you have to know how to graph a piecewise function. I don't ask you to do it here, okay? So what I suggest you do to practice is I gave you a worksheet in class and you graphed a whole bunch of them. So what you can do is take out graph paper, regraph them, and make sure it matches the work that we had done on that worksheet. For number 7, f of negative 5. Negative 5 is less than negative 1, so I would plug that into the first equation. I would do 3 times negative 5 squared minus 8, which gives me 67 for number 7. Number 8, -1 falls into the interval x is greater than or equal to -1. So I'm going to plug it into the second equation. So I would do 2 times -1 plus 4, which gives me 2. And then 3, for f of 3, that falls into the x is greater than or equal to -1 domain. So I would do 2 times 3 plus 4, which is 10. Okay. Number 10, determine the average rate of change. So you have to evaluate twice and then plug those values into the slope formula. So I need -2 and +2. So f of -2, -2 is less than -1. So I plug that into the top equation. I would do 3 times -2 squared minus 8, which gives me 4. And then for 2, 2 is greater than or equal to -1. So I would do 2 times 2 plus 4 gives me 8. But again, I need the average rate of change formula. So it would be y minus y over x minus x. Okay, you could write 2 minus -2. It's the same thing as 2 plus 2. So a minus 4 is 4 over 2 plus 2 is 4. 4 over 4 is 1 for the average rate of change. Numbers 11 and 12 rationalize the denominators. So to rationalize these denominators, you are going to multiply the top and the bottom by the radical that's in the bottom. So 5 times the square root of 10, that's 5 square root of 10, divided by the square root of 10 times the square root of 10 is 10. And then you have to see, can I simplify the radical? Do it if you can, and then simplify any fractions that you have. So 5 over 10 is 1 over 2. So really this is the square root of 10 divided by 2 for number 11. For number 12, I'm going to multiply the top and the bottom by the square root of 6. So 2 square root 3 times square root 6 gives me 2 square root 18 divided by square root 6 times the square root of 6 is 6. The square root of 18, that's 3 square root 2. So 2 times 3 square root 2 is 6 square root 2 divided by 6. And then my 6's cancel out, and this is really just the square root of 2 is your answer to number 12. Numbers 13 and 14 are simplifying the radicals. So this is going to be -4 times something. So 147, this is a square root. The largest perfect square that goes into 147 is 49 times 3. The square root of 49 is 7. I still have the square root of 3. I'm going to leave some room for the letters. For the x, 2 goes into 4 2 times with no remainder, so no x in the radical. For y, 2 goes into 7 3 times with a remainder of 1. And for z, 2 goes into 2 1 time with no remainder. And then last, I would just multiply these together. It gives me -28 x squared y to the third z times the square root of 3y as your final answer. For number 14, so now it's the same thing, but now it's just it's a cube root. So we're going to do 2xy times something. So the largest perfect cube that divides into 1024 is 512 times 2. The cube root of 512 is 8. I'm left with the cube root of 2. Leave yourself plenty of room. Remember, this is a cube root, so now we're dividing by 3 for the exponents. So for the x, 3 goes into 8 2 times with a remainder of 2. For y, 3 goes into 6 2 times with no remainder. And for z, 3 does not go into 2, so z squared just gets brought down inside of the radical. And then last, I multiply these two out front. So 2 times 8 is 16. X to the third, y to the third, and you are left with the cube root of 2x squared z squared. And then we have 2 work problems on the bottom. So for number 15, when Jack and Jill work together, it takes them 2 hours to, what are they doing? To rake the front lawn. So we have Jack plus Jill equals both. So when they work together, it takes them 2 hours. When Jill works alone, it will take her 4 hours and 30 minutes, or 4.5 hours. So I'm going to write 4.5. How long does it take Jack? So my LCD, I would multiply x times 4.5 times 2, gives me 9x. So my equation turns into, this is a 9, turns into 9 plus 2x equals 4.5x. Subtract the 2x, 9 equals 2.5x. Divide by 2.5, I get x is equal to 3.6. I know it says nearest hundredth. If you want to put the 0, you can, but you don't have to really, because that is an ending decimal, and it's 3.6 hours. Okay? And then last question. Velma can solve a murder in 9 hours faster than Fred can. So we have Velma plus Fred equals both. If they work together, it will take only 20 hours, so both is 1 over 20. So if Velma, you could do this one of 2 ways. If Velma is x, then Fred takes 9 hours longer because she works faster than him, so it would be x plus 9. What I'm going to do, I'm going to say that Fred takes x amount of time. So Velma is going to take his time and subtract 9 hours because she works at a faster pace. So my LCD for this is 20x, x minus 9. You have to put them all together. So my first fraction, x minus 9 cancels. I have 20x plus 20 times x minus 9 equals x times x minus 9. So this is 20x plus 20x minus 180 equals x squared minus 9x. I set it equal to 0. 0 equals x squared should be minus 49x plus 180. When I factor this, I get x minus 4 times x minus 45. So I set up my t-chart. I get x is equal to 4 and x is equal to 45. So remember though, you're looking for both Fred and Velma. So Fred is x. That's what we have labeled back up in the equation. So Fred is 4 hours in this case. If Fred is 4 hours, Velma is 4 hours minus the 9 hours is -5. So this does not work because it can't take Velma a negative amount of time to solve the murder. Okay, so the other one should work. So if Fred takes 45 hours, then Velma takes 45 minus 9, which is 36 hours, which makes sense. Okay, so Fred, it takes him 45 hours, and Velma, it takes her 36 hours. Okay, if you have any other questions, Extra Help is after school on Thursday, December 19th. Have a good night.